The second part of section 3 is solving quadratic equations by factoring. So we're going to recall all of our factoring rules and solve these equations using these methods. The first thing you always want to do is check for your GCF, right? If we can factor out a GCF, it's going to make the factoring a lot easier. Then if there are two terms, we have three different options. We have a difference of squares, a difference of cubes, and a sum of cubes. So recall, there's no sum of squares. Difference of squares, sum of cubes, and difference of cubes. Those formulas are listed as is. So remember, when it's a difference of two squares, you find the square roots, and then it becomes a minus b, a plus b. Cubes, remember, are perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, etc. When you have a difference in sum of cubes, our formulas are the following. A minus b, so whatever the cube roots are. Then we square the first cube root, multiply the two cube roots, and then square the second cube root. So all of these examples are done out. Again, these are all skills you should have already learned that we can go over in more detail if you need. When it's a trinomial, we can have it be a perfect square trinomial, which is a quick shortcut. If we have two perfect squares and the middle term is twice the product of the two, then we can just take the two square roots and pop them into our formula. We have trinomials where the leading coefficient is 1, and then we have trinomials where the leading coefficient is not 1. In that case, you either need to use guess and check or factoring by grouping. And then if we have 4 or more terms, we are going to factor by grouping. Okay, so please refer back to this chart if you're really weak with your factoring. All the examples are done out. Let's actually do a few together though. Okay, so if we look at question 1 has 2 terms and there's not a GCF. So if it has 2 terms, we ask ourselves, is this a difference of squares, a sum, difference of cubes, or maybe it's neither? In this case, I have subtraction, so it's a difference, and I see a square. And 64 is also a perfect square. So this is a difference of 2 squares. What I'm going to do is take the square root of m squared, which is m, and the square root of 64, which is 8. I now pop it into my formula that says to multiply by the sum and difference. So I'll have m plus 8 and m minus 8. There's the factorization. Now we take those factors and set them to 0 and solve, which gives me negative 8 and positive 8. We can write our answers in a solution set because there are 2 answers. We can write negative 8 and positive 8, or plus or minus 8. And there's my answer. Okay. Let's take a look at number 2. So for number 2, what we really need to make sure we do first is make sure that that equation equals 0. And I kind of list those steps up above. So we need to subtract 7 to make the equation equal 0 anytime we see a quadratic. I now have 7p squared minus 23p, and then 13 minus 7 is 6. So what we have here now is a quadratic with a leading term. There's no GCF amongst 7, 23, and 6, so I need to factor this with the leading term. You have 2 options, factoring by grouping or factoring with guess and check. If you know guess and check, use that method. It's faster. If you don't, then let's recall how we do grouping. So for factoring by grouping, we ask ourselves what multiplies to the product of 7 and 6. So that's 42. And then what 2 factors of 42 add to negative 23? So because it has to be a negative, we know we'll have negative values. So we could go on and on, right? We could do negative 1 times negative 42. That gives me positive 42, but that does not add to negative 23. So we keep listing our factors of 42, and lo and behold, the next set here, negative 2 times negative 21, yes, multiplies to positive 42 and adds to negative 23. So now I'll rewrite this, 7p squared minus 2p minus 21p plus 6 equals 0. I rewrote that middle term with our 2 terms. I'll now group, include the signs. So with my first grouping, they just have a p in common. So I take out the p and I'm left with 7p minus 2. The next grouping has a -3 in common. Again, I pulled out the negative because I want inside to have a subtraction. So this gives me 7p minus 2. Those two quantities in the parentheses matched, so I did it correctly. So my factorization is p minus 3 times 7p minus 2. I take those factors and set them to 0. The first factor would give me a +3, and the second factor would give me 2/7. And there are my solutions. Okay, I want you to try a few more of these. So try 3, 4, 5, and 6 on your own. I'm going to now do 7 and 8 with you. So these ones are a little different because notice the powers are slightly different. Okay, so we have two options of how we can do this. One option is called U substitution, which I'm going to use that with you. So if I use U substitution, what that means is I look at that B term, that middle term, as long as I'm in standard form, and the variable that's attached to that, I'm going to call that instead U. So U is going to be x squared. So I'm going to replace now all my x's with u's. Well, if u is x squared, that means x to the fourth is u squared, because u squared, x squared squared gives me x to the fourth. Then we'll have minus 3u, because again, x squared is u, and then minus 10. And I'm just going to solve this now. Basic. Leading coefficient is 1. It's a trinomial, so what multiplies to -10 adds to -3. That's u minus 5 and u plus 2. I solve that and I get +5 and -2. However, remember, those are your answers for u. We still need to know x. So now comes that, again, substitution part. I go back in and where I see a u, I put x squared. And so now I solve that. Well, how do I undo this? We take a square root. Remember, when you take a square root, you get the plus or minus. I can't simplify root 5, so I just get plus or minus root 5. Now solve the second one. Same deal. I need plus or minus. Remember here we have a negative out front, so we'll have I root 2. So we have 4 solutions here. We have plus or minus root 5, and we have plus or minus I root 2. We're going to try something similar for number 8. So I want to ask you, what do you think our u should be? Remember, it's what's attached to that second term. So hopefully you got it. U should be x to the 1/4. So now I rewrite this as u squared because 1/4 all squared, right? If I said x to the 1/4 all squared, we multiply back-to-back exponents, so that would be x to the 2/4, which gives me 1/2. And that's what we have. So that's the little check there. So I have u squared minus 2u minus 8 equals 0. Again, pretty easy factoring. What multiplies to -8 adds to -2. That's -4 and +2. It's going to make that 4 not look like a u. We set those to 0 and we get u equals 4 and u equals -2. But again, we're not looking for u, we're looking for x. So I substitute in x to the 1/4 equals 4 and x to the 1/4 equals -2. Now, how do I do that? Well, recall what this is really saying. Let's see if you remember this. This is really saying the 4th root of x equals 4. Okay, this will be a good tie-in to what we're going to be doing soon. When we have a rational exponent like that, remember the denominator is our root. So this is really saying the 4th root of x equals 4. If I was to solve that, how do I undo 4th root? We raise it to the 4th power. So I do 4 to the 4th power, and that gives me 256. So for the next one, we'll do the same thing. We'll write this as the 4th root of x equals -2. However, what you need to remember is that we can never take an even root and have it be a negative number, right? You would need a plus or minus out front for it to be negative, or it has to be an odd root. So this one would not give you a solution at all. All right, let's look at one application where we could have our factoring and maybe some of our review of our graphing parts as well. So a position function is a very popular function that we'll use in math, in calculus, in physics. If you are taking physics, you may have already seen this. So position function is h of t equals negative gt squared plus what we call v naught. Whenever you have a subscript of 0, we say v naught times t plus h naught. And what do all those mean? Well, g is gravity. It's going to end up becoming a negative 16 out front if we're talking about feet per second, or it'll be negative 4.9 when we're referencing meters. That's the force of gravity, depending upon what units we use. V naught is your initial velocity, h naught is your initial height, t is time, and then the function of h of t is what that new height is. So if we take this scenario of Laura diving into a pool from 48 feet high, her initial velocity is 8 feet per second. We want to find the time she enters the water. So we want to fill in all the different parts. Okay, so let's circle some of the key things. Laura dove into a pool from 48 feet high. What does that mean? That 48 represents her initial height. So h naught is 48. We have our initial velocity, they say, is 8 feet per second. So v naught is 8. Now, g we can figure out because we're talking about feet, so I'm going to use negative 16 in there, or we'll say 16, but we'll plug in and have that function say negative 16. And what that is the force of gravity. Gravity keeps us down, so that's why we have our negative, right? If an object goes up, it must come down. And then we're looking for time, so it means we need to know what h of t is. So h of t is the new height. Well, what are we looking for? The time she enters the water. So the height of the water is 0. So now I can set up an equation. Okay, so remember, here's the general position function. And we'll fill those pieces in. So I'm looking for when I have a height of 0. Our gravity is negative 16. We don't know our time. That's what we're looking for, so I leave t. Our initial velocity is 8. We don't know t, and our initial height is 48. So here's my equation. So I want to find time. So how can I do this? Well, I'm going to try to factor. Let's see if it's factorable. First thing I notice is that these all have a GCF of 8. Now, I prefer having my leading term be positive, so I'm going to actually factor out a negative 8. This will now give me positive 2t squared minus t minus 6. Now I look to continue factoring. So you can use guess and check or factoring by grouping, your choice. If I use guess and check, we're asking ourselves what multiplies to negative 12 and adds to negative 1. So that would be negative 4 and positive 3. So I'll have 2t squared minus 4t plus 3t minus 6. If I group those, I'll take out a 2t. I'm left with t minus 2. Take out a 3, left with t minus 2. So my factorization is the negative 8 to begin with, and then 2t plus 3 and t minus 2. When I set those to 0 to solve, I don't care about the negative 8 because that doesn't have a variable. The 2t minus 3 will give me negative 3 halves, and the t minus 2 will give me 2. Do I want both answers? I'm looking for when she enters the water, so I don't want a time of negative seconds. That's the past tense. What I want is the positive. So she will enter the water, and make sure to put a label, after 2 seconds. Now, the other part of this question says, what is her maximum height? And I'm going to leave that part for you to try. That's a review from our last section. When I say find a maximum, what does that really mean to do? It means find the vertex. So I want you to use your skills from our last section to find the vertex given the equation we've come up with. And don't forget to go back to try the other factoring problems.